Good morning to all of you. In the last class, we have completed the central tendency where we have discussed about mean, median, mode, and worked out number of examples for ungrouped data, grouped data with class intervals and all. Uh, if you have any problem in understanding, please let me know. I will try to clarify it. Even I will be happy to repeat the things if you don't understand, because what's more important for me is to understand what I am telling, not completing the syllabus, because completing the syllabus is not a big thing. Hardly I need another 2 hours to complete the portion that has been allotted to me. Still we have a lot of time, so that's why what I feel is, if you have not understood anything starting from evolution to this biostat, please feel free to send your questions, doubts. uh, so hope that you will respond uh, to my request. Today let me continue with the topic, what is known as the measure of dispersion. Measure of dispersion, they have specifically mentioned some of the topics in this measure of dispersion because it's a very lengthy topic, and uh, interesting also. What is this measure of dispersion? All of you know now how to calculate the central tendency, that is the most central value, or what you call the averages. When you take out the average is, all of you know that it is the most common number. But whereas in any given set of data, there may be values which may be showing deviation from this uh, actual central value. For example, if there's a group of 10, and if each one have scored different uh, set of marks in the final examination, if you ask me the average, I may say that average score of the particular 10 students is 70%. But all of you know that many must have scored even less than 70, many must have scored more than 70 also. But when you have considered the average or the central value, you got it as 70%. But now, if you want to know how the individual values deviate around the central value, or how these individual values vary from this central value, that is known as measure of dispersion, or also called as measure of variation. It is the deviation of the individual values around the central value of the data. Probably if I say that it is nothing but the measure of variation of the item, you may not understand unless I take out an example. See, here there are three coconut trees. You have harvested the coconut trees 4 times in a year. First tree, in the first harvest it gave 10, second harvest also 10, third harvest also 10, and in the fourth harvest also it gave 10 coconuts. All total is 40. Whereas the second tree, in the first harvest you got 12, second harvest 8, in the third harvest you got 9 coconut, and in the fourth harvest you got 11. But the total is 40. Whereas the third tree, in the first harvest you got 22, in the second harvest you got only 2 coconuts, in the third harvest you got 13, and in the last harvest you got 3. If you make a total, that also comes to 40. So if I say what is the average, first tree in 4 harvest average is 10. In the second harvest also its average is 10. We got 40 by 40 trees. Sorry, 40 this thing. Totally 4 harvest. 40 by 4, 10. 40 by 4, 10. 40 by 4, 10. So now average yield is 10 in all the trees. You can see the difference. In the first tree, the value is very similar to that of the average. Average is 10. In each harvest, it yielded 10. So it is the average and the harvest. Each harvest of the code tree number one is similar to the average. But whereas in the second tree, the individual values slightly differ or scatter from the average. First it got 12 more than average. In the second it got 8 more less than average. In the third also it got 9 less than the average. And in the fourth 11 1 more than the average. And here though the average is 10, the individual values differ or scatter, we can say. Individual values differ or scatter from the average. You look into the third tree. See, the individual values differ much more from the average. First, one time it is 22, sometime it is 2, 3, some one time it is 13, like that. The difference, the, the values differ much from this average. And this difference is called as variation or dispersion. Now, what do you mean by this? What is the significance of this measure of variation? This understanding the variation helps to determine the reliability of an average. Many times average may be there, but it may not be reliable. So it has to determine the reliability of the average. And of course, it also serves as a basis for the control of variability. When you get two or more data regarding the variability, you can calculate, compare the values, which is more reliable. In my opinion, the first tree is more reliable every time it goes. Second tree is okay, it is slightly reliable, but the third tree, if you calculate the variable, it is highly unreliable. The measure of dispersion is of following types. One is range, quartile deviation, mean deviation, and the central deviation. So, as far as your syllabus is concerned, they have mentioned only two. One is range and another one the standard deviation. Quartile deviation, mean deviations are not that much important. So that's why from your syllabus that has been omitted. Now, first let's know about the range. What is this range? Range is nothing but measure of deviation or dispersion or variability. It's a measure of variability undoubtedly. How to calculate? It is the difference between the lowest value and the highest value in the set of data. So that's why if you want to put an equation for that, range equal to largest value minus smallest value. L R equal to L minus L, S. L is the largest value and S is the smallest value. So this range gives an idea of degree of variability. It gives us the degree of variability in a set of values. How? To understand this, let's work out on one problem. The yield of a coconut tree, single tree you take, on 5 occasions, 5 times in a year, if, that person has harvested from a single coconut tree, he got the coconut 22 ones, 8 ones, 12 ones, 5 the fourth time, and 13 on the fifth time. So now you calculate the range. Here, out of this 22, 8, 12, 5, and 13, the largest value is 22 and the smallest value is 5. Range equal to L minus S. 22 minus 70. So the range what you get is 70. That means the measure of variation in this is 70. But most of the time we depend on not on the range but the coefficient of the range. When the range is divided by sum of the extreme values, the resulting figure is called as coefficient of range. When the range is divided by sum of the extreme values. So that's why the range coefficient of range equal to R. That means large R L minus S. R means L minus S, largest value minus smallest value divided by largest value plus smallest value. That is the coefficient of range. L minus S divided by L plus S. So this is what you call the coefficient of range. So here also you can calculate the coefficient of range. L minus S how much? 17. L plus S is 22 plus 5, 27. 17 divided by 27. That's the coefficient of range here. What are the advantages of range? Undoubtedly, it is very easy to calculate. And it also helps us in studying the variation in a set of values. And when you calculate the range for different data sets, the variability between the data you can measure. Especially, this is used to study the increase in price of commodities and all. It was not now. Demerits of there are some demerits also. It's a crude method of calculation. And here only two extreme values are selected. Largest value as well as the smallest value. The values in between are neglected. If the extreme values are unusual sometimes, then range will be misleading. This is about the range. Then about this quartile deviation, it has not been in your syllabus. Then the next one is the standard deviation. This also measure of dispersion or measure of variation. That is what you call standard deviation. This is compared to range, this is more reliable but difficult to calculate. Because in range you have only two. Even in the coefficient of range also you are considering only two extreme values. Here it is not so. Then what is the standard deviation? It's also a measure of dispersion. How the data varies from the average. What you are going to calculate. But the standard deviation is calculated as the square root of the mean of the squares of deviation from the mean. Square root of mean of the squares of deviation from the mean. In the sense, first you have to take the central tendency, that's the mean. Then, once you know the mean, then you can calculate the standard deviation. It has been represented as SD or sigma. Most of the time we use the term sigma, or even SD also stands for standard deviation. The formula to calculate the standard deviation is standard deviation equal to square root of summation x minus x bar. X bar means mean, central tendency, whole raised to 2 divided by n, where summation d, sorry, sigma d, this is small sd, standard deviation, x is the value of observation, and x bar means mean, which all of you know, n is the number of items, and summation, the sum of total. What are the merits of the standard deviation? Standard deviation is very rigidly defined. All values are considered for calculation. No value is left out. Squaring makes it negative signs to positive sign. And the standard deviation is less affected by sampling. And once you get the standard deviation, you can use it for further calculations also. What are the demerits? Calculation is complex and it is affected by each and individual value because all values are considered. So now you may be asked to calculate the standard deviation from the following data. What is given is the weight of the fishes in grams is been given. 8 grams, 6 grams, 7 grams, 5 grams, 6 grams, 10 grams, 8 grams, 6 grams, 7 grams, and 7 grams. For this, first you have to calculate the x bar, that the mean. The mean means summation x upon n. X is the value of item and number of item. How many items there are? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items. Number of items are 10. What is x? Summation x? The value of all these items put together. So if you total it, 8 plus 6 plus 7 plus 5 plus 16, 6 plus 10 plus 8 plus 6 plus 7 plus 7, you will get summation x. And the value of summation x is 70 if you total it. Then what is the total number of items? 10. 70 by 10 equal to 7 grams. What you got is x bar, the mean. Once you get the mean, then you can find out the deviation of each value from the mean. How? X minus x bar. X bar is the mean. How much the mean show the deviation from each value. So then you make three columns. In one you can write weight of the fishes in grams. What is that? Is the x. 8, 6, 7, 5, 6, 10, 8, 6, 7, 7. Then you calculate x minus x bar. X bar value you have already calculated, that is 7. So x minus x bar equal to 10 minus 8, sorry, 8 minus 7, 1. Next one is 6 minus 7, minus 1. Third one is 7 minus 7, 0. 5 minus 7 means minus 2. 6 minus minus 7, that is minus 1. 10 it is plus 3, when the value 8, 1, 6 minus 7 means minus 1, 7 minus 7 means 0, 7 minus 7 means 0. So this is the x minus x bar. What we need here as far as the calculation, summation x minus x bar whole square. Now what you do is x minus x value you got it and make it x minus x whole square. Whole square of 1 is 1, minus 1 is plus 1, 0 is 0, whole square of minus 2 is 4 plus 4, whole square of minus 1 is 1, whole square of 3 is 9, whole square of 1 is 1, minus 1 is also 1, and for 7 it is 0. Now what you require is the sum of this x minus x bar square. The value of x bar square, you make a total of all x minus x bar square value. That is summation x minus x bar square value. It is 18. Now you calculate the standard deviation using this formula. What is standard deviation? Square root of summation x minus x bar whole square divided by n. Already I have given you the formula. See, x summation x minus x bar whole square divided by n. What is the value of summation x minus x bar? It is 18. What is the value of n? Number of items 10. 18 divided by 10 equal to 1.8 grams. So again this is spelling mistake. 18 divided by 10 is 1.8 grams is the standard deviation. You can take another example here where you have a group data. Deviation for the following group data which shows the length of the fishes. Length is, and second column shows the number of fishes. One fish measuring 5 centimeters, two fishes measuring 6 centimeters, five fishes measuring 7 centimeters, five more fishes measuring 8 centimeters, and three fishes measuring 9 centimeters, and three fishes measuring 10 centimeters, and one fish measuring 11 centimeters. That's the group data. Now, for the purpose of calculation, you have to draw a 6 vertical columns. Length of the fish you write in the x column. Frequency of those fishes in the second column. And the value of summation f you have to measure. So first you have to take down the x bar. X bar equal to summation f divided by n. Summation fx. What is this? Summation fx. This is the summation fx. That's 160 if you make a total. F means this x. 5 into 1 5, 6 into 2 4, 12, 7 into 5 35, 8 into 3, 8 into 5 40, like that. Summation fx equal to 90. Frequency, if you make a total of all the frequencies, it is summation f20. Now you know the mean. X bar equal to 8. The value of x bar, and in Standard deviation, what you need is this formula. You should be able to apply the formula. X minus x square, what you call. The value of x minus x bar. X bar is 8. So minus 8 minus 5 minus 8, 3. 6 minus 8 minus 2. 7 minus 8, so minus 1. 8 minus 1, 0. 8 minus 9, 9 minus 8, 1. 10 minus 8, 2. Then the 3. Once you put all these data, now you have x, you have f value, you have fx value, and you have x square, x bar value also. If you total all the frequencies, it comes to 20. If you total fx, frequency and the length, it becomes 160. Now, in order to get the deviation, square the deviations to get x minus x bar and enter in the fifth column. Now multiply x minus x bar with x bar to get f into x minus x bar whole square, and you enter it in the the fourth column. See here, f into x minus x. Here it is x minus x bar square. What is x minus x bar square? X bar square is 8. This is the value of x. X minus 8. What is the x bar value? 5. X value is 5. So 5 minus 8. So answer is minus 2. 6 minus 12. Sorry. Uh, 6 minus 8 minus 2. 6 minus 7 minus 1. 8 minus 5, 0. 9 minus 3. Here, in order to get the 1, 2 and 3, you will get. So what you have to do is simply multiply the length with the frequency. Fx you will get. Once you get the fx value, you can calculate x minus x bar divided x by, where the value is 8 in the given set of data. The summation fx is 160. If you make a total of all these things, it will come to 160. We are not interested only in x minus x square, x bar. Our interest is x minus x bar whole square. So x minus x bar whole square of minus 3 equal to 9, minus 2 equal to 4, 1 minus 1 is 1, so on and so forth. So here x minus x bar square, the square of minus 3, minus 2, minus 1, 0, 1, 2, 3. That will give you minus 3 whole square equal to 9, minus 2 whole square equal to plus 4, minus 1 square means 1, 0, 0, then 1, 1, 2 square is 4, 3 square is 9. Now once you get x minus x whole square multiplied with f, that's the frequency. 9 into 1, 9, 4 into 2, 8, 1 into 5, 5. Here the 0 is there. So f minus x bar is 0. Then the fx value, we will take here only the f value. F into 1, 3, 4 into 3 is 12, 9 into 1 is 9. So summation f into x minus x bar equal to 46. Once you got this value, you can substitute that value in the formula. Standard deviation equal to square root of summation f into x minus x bar whole raised to 2 divided by summation f. We know that summation of f into x minus x bar square equal to divided by it equal to 46, what we have taken. So then what about EF value? EF value is 20. Frequency, if you make a total of all the frequencies, it comes to 10. So you substitute that in the following formula. Square root of fx into x minus x bar whole square divided by summation f. X minus x bar square, we know that, 46. Summation f x minus x bar equal to 46. Then the square root of 46 divided by 20. Then the answer comes to 2.3, sorry, 2.3 to 5 grams. That's the measure of this, particularly the standard deviation. One is the range and second one is the standard deviation. And uh, I may need another 15-20 minutes to complete this, but time is not permitting me today, and at the same time we are far ahead as far as the syllabus is concerned. Probably tomorrow I will discuss with you again and complete this biostatistics.